take a moment before I go into sort of the trajectory of how we got where we are and what we're doing to provide you with an example. So Lucid Design Group, as I say, is a small company. It's based now actually in Oakland, California, where my three colleagues, all former Oberlin students, are located. And I thought I'd show you one of our installations hot off the press. I think, I'm not sure if this has gone public yet, but it's a display that we've developed for Elon University, which is a small university in North Carolina. Let's see if I can figure out how to get here for a moment. So I'm going to take you for a moment to the website of Elon University. So students at this campus, a campus actually that's known like Oberlin for social engagement, community activism, can click on a website. They can, here, let me show you what we've done there. They have 8 dorms on campus. Does this thing all fit on here? It doesn't quite fit on here, but that's probably okay. They have 8 dormitories on campus. They range in size from about 93 to 174. And what we've done is to install instrumentation in the dormitories on this campus that measures their electricity use and that will eventually measure their heat consumption as well. Close that for a second. So students at this campus can now get on this website, click on this little tab here, and see how much electricity their particular dormitory is consuming. So this particular dorm is HBB. I don't know what HBB stands for. Let's see if I can get this to fit a little bit better on the screen. I'm not a Mac user. Maybe I can't. But at any rate, what it's displaying here is how much electricity has been used in each of the hours during the last day. This is displayed here in energy units, but students have the opportunity to translate this into units that might be more familiar or comfortable to them. They could express that in dollars. They could express it in pounds of CO2 emitted so far today. There's a whole range of different choices they could make in terms of what units they express it in. They could choose to express it on different time scales. That's today's data, but they could look at the last week's worth of data and begin to develop an intuitive sense of how their activity within the built environment is impacting the world around them. So to get that sense that, hey, it's a Saturday today, they consume more energy on a Saturday than they do on other days because they're spending a lot of time in their dormitories. Again, the concept is to give students a sense in real time of their resource consumption within the environment. We've also developed let's see if this is going to work. The capacity to compare with single other dorms. So here they're comparing 2 dorms against each other, so they can see their consumption relative to another dorm's consumption. How am I doing relative to my someone else's consumption? And also the capacity to run competition. So here's a competition running between dorms. This was started, I think, on January 1st and is going to run until February. You can see the winning dorm, the dorm that's consuming the least energy, is at the top. They can click on a button and see how much they're using at this particular moment, but also how much they've reduced relative to a baseline period. So this dorm is using only 24% of the energy that they consumed during a reference baseline period. They have saved 1,588 kilowatt hours of electricity so far this competition, and their top day was January 31st. That's when they did the best on this. So that they can begin to, again, get this sense of how they're doing relative to their peers and more of an intuitive understanding of how their activity in the built environment is affecting the larger environment. Again, they have a choice of expressing this in a variety of different units. Hamburgers here. All right. Again, the idea is you want to reach people where they are. Some people think in kilowatt hours, not many. A lot more people probably at this point think in money. And some of us are beginning to think in units of CO2.